Hey, welcome! Today we are going to dive into something you probably use all the time but maybe don't think about. Printing. Seriously, we're going to go on this incredible journey from monks with ink-stained fingers all the way to that laser printer sitting on your desk right now. So, let's get into it. Our story starts where every story used to, with a single, handwritten word.
Okay, I know what you're thinking. That sounds like a trick question, right? A wine press and my printer. But I promise you, the answer connects a medieval vineyard to the very idea of modern knowledge. By the end of this, you'll see exactly how these two seemingly random worlds are totally linked.
All right, first, we need to wind the clock way back. Back to a time when information moved at a snail's pace. A time when every single word was a deliberate, manual, and often painstaking act.
I mean, just try to imagine being a scribe. Every letter, every single page copied by hand. A whole book could take you months, sometimes even years. Now, woodblock printing was a huge step forward. You'd carve an entire page into a block of wood. But what if you made a typo? Yep, you had to carve the whole thing all over again. Knowledge could spread, but it was moving through molasses.
And this brings us to the man who finally broke that bottleneck, Johannes Gutenberg. But here's the thing you have to understand. His real genius wasn't in one single invention. It was in building a whole new system, an information machine.
And here it is, the answer to that question from the beginning. Gutenberg brilliantly combined three key ideas. First, he made individual metal letters that you could move around and rearrange forever. Second, he used a new kind of oil-based ink, one that was thick enough to actually stick to the metal. And third, the big one, he adapted the screw press from a winery to provide the huge, even pressure he needed to get a perfect print. And this is the part that is just mind-blowing. The sheer scale of the change. We went from one book taking months of labor to literally hundreds of books in just a few weeks. This wasn't just a small improvement, it was an information explosion. Suddenly, scientific discoveries, new ideas, philosophies, they could all be copied and spread across an entire continent in months, not decades. This really lit the fuse for the Renaissance, the Reformation, the whole scientific revolution. For the first time ever, an idea could travel faster than an army.
Okay, let's fast forward a few hundred years to the 1800s. The world is industrializing, factories are popping up everywhere, and the demand for printed stuff, newspapers, books, you name it, is absolutely through the roof. Printing had to get a whole lot faster.
And you can just see the leap in scale right here. A hand press on a good day might manage a few hundred pages an hour. But then look at that second bar, the steam-powered rotary press. It could churn out thousands. It's not even a competition. It just completely blows the old way out of the water. This was the moment printing went from a craft in a workshop to a full-blown industrial factory. And this was a total transformation. Human muscle power got replaced by the tireless force of steam. Those flat printing plates were swapped out for massive rotating cylinders. And instead of feeding in one sheet of paper at a time, you had continuous rolls of paper flying through the machine. And what did all that give us? The daily newspaper, the affordable novel. This wasn't just faster printing. This was the engine of mass literacy. It changed society from the ground up.
You know, for centuries, printing was all about force, about physically pushing ink onto paper. But the next great leap forward was way more elegant. It didn't rely on brute strength, but on a really simple principle of chemistry.
And this is the big aha moment for modern analog printing. It all comes down to a fact you learned in elementary school. Oil and water don't mix. That's it. Offset printing uses this simple idea to control exactly where the oily ink goes on a printing plate with incredible precision. No more carving, no more raised letters, just pure chemistry at work.
So how does it actually work? Well, you put an image on a metal plate. The oily ink sticks only to the image parts, while a thin layer of water keeps the blank areas totally ink-free. Then, and this is the really clever bit, the image isn't pressed right onto the paper. It gets transferred, or offset, onto a rubber blanket first. And that flexible rubber surface is what creates a much sharper, cleaner, more perfect image on the page.
So, offset printing became the undisputed king. It gave us our vibrant world of glossy magazines and colorful books for most of the 20th century. But in the background, a digital revolution was quietly brewing. And when the personal computer finally arrived, it did something Gutenberg could never have dreamed of. It took the entire print shop and shrunk it down to a little box that could fit on our desks. So let's look inside that inkjet printer you probably have at home. It is a quiet little miracle of microphysics. You've got two main types.
The thermal kind basically boils a microscopic pocket of ink to create a vapor bubble that shoots a droplet out. It's like a tiny, tiny steam engine. Or you have the piezoelectric type, which uses a crystal that literally flexes and pushes ink out when you apply electricity. We're talking about millions of droplets, smaller than a human hair, being fired with pinpoint accuracy. The physical printing plate was officially obsolete.
And what about the laser printer, the workhorse of every office? It's pure electrostatics. You know that static shock you get from a doorknob? It's that, but controlled with unbelievable precision. A laser beam, moving impossibly fast, draws your document onto a charged drum, creating an invisible image made of static electricity. Then, charged powder, that's the toner, sticks only to where the laser drew. Finally, heat and pressure fuse it all to the paper. It's basically printing with light, and it's what gave all of us the power to create professional quality documents instantly.
So, let's bring this all together. The journey from Gutenberg's workshop to the device sitting next to your computer is really a story about replacing physical effort with pure information.
And this table just lays it all out, plain and simple. Look at the difference between the mechanical and digital eras. It's night and day. We went from manual labor and steam power to software control. We went from heavy physical metal type and plates to nothing. No physical medium at all. A messy, slow, complicated setup has been replaced by an instant print command. An entire building, a whole print shop, has been shrunk down to a single device on your desk. The change is just absolute.
I mean, you can tell the entire story of printing just by looking at the science it used. It started with raw physical pressure. It evolved into elegant chemistry. Then it harnessed electricity. Then it controlled light itself. And now it's become a function of pure data, the ones and zeros that run our entire world. And in the end, that's what this has always been about. From Gutenberg's Bible to that report you just printed out, every single page is a physical manifestation of an idea. It's this incredible technology that lets us give our thoughts weight, give them permanence, and give them the power to change the world.